About open manufacturing. First, we are going to introduce our three speakers who are joining us in this afternoon, and then they will make a 10-minute presentation about their research and projects and everything related to open manufacturing. First, we have Carmelo Rodríguez Cedillo. He's co-founder of PKMN Architectures. He is an architect, and he has just launched a new project called Pequeñas Grandes Casas, who will now be explained together with other three open manufacturing projects. Then we have David Cuartielles. He's co-founder of Arduino. He is also professor of interactive design in Malmö University in Sweden. And he's also created a platform to help students experiment with open manufacturing, and you will probably explain this a little further in detail. Then we have Peter Troxler. He is a professor of applied sciences at the Rotterdam University. He's also a researcher, and he will explain all the conclusions of his research along all this time and his projects he's now involved. First, we're going to start with the presentation of Carmelo. Then, after all the presentations, we will have a Q&A session, a discussion, and we are not that many people, so we can create a quite flexible discussion or Q&A session. So, Carmelo, you have the floor. My name is Carmelo. I come from PKMN. We're a group of architects, and I will try to explain in 10 minutes a bit of my life, and I will try to explain some of the projects that we are involved in, and which have a common element, which is not only open manufacturing or digital manufacturing, but open design. I am going to start with some words by Santiago Cerón.
De estilos y no deja nunca de cambiar. Cada año se ofrecen como un par de versiones nuevas de lo que es o de lo que debiera ser el rock and roll. Pero hay algo que no varía en estos últimos 30 años, y es que el rock and roll ha supuesto la posibilidad de recuperar el uso de la música para la cotidianidad y ofrecer a las clases trabajadoras de todo el mundo la posibilidad de experimentar, de incidir en la transformación de su medio, cosa que antes estaba reservada exclusivamente a las élites, ¿no?
For me, this definition of rock and roll could perfectly be a definition of open design, how to open a process, a thinking process, a manufacturing process, so that everybody, as we all as citizens, and not only as experts or designers or professionals, but just as citizens, we can influence in our environment and transform our reality beyond distinguishing among the different articles in a catalog. I'm going to first talk about urban scale and then domestic scale on how to open design processes. Concerning urban scale, this all is related to the idea of going beyond a standardized planning and have a customized city plan, so we can all be protagonists of our own cities and transformers of our environment. The first project is called Las Tres Marías, and this was carried out in Venezuela. This belongs to a global project called Espacio de Paz, Space for Peace. 5 groups joined in this common project to work in a series of neighborhoods in Venezuela having problems with violence, etc., and trying to create a common public space in 1 month, having the excuse of training a group of youngsters who had problems with drugs or violence, etc. So the design is being opened, and everyone talks about how to create the design, and this is a tool to have a social transformation, which is necessary in this particular neighborhoods and help these youngsters to be productive beyond drug trafficking. So here we can see some images. The important thing is not a project. The important thing was that the decision-making process was by everyone. All the youngsters were involved, and the final aim or target of this project of open design basically tries to create a cooperative among all the workers in the neighborhood so that they can be in the future the protagonists in the sense of being the main agents or actors and makers of their own public space, and there is no need for a construction company to come from the outside and change it. This was a dump site and a hub for drug trafficking, and we created this common public space with a lot of retro technology. We didn't use any Fab Lab. This was quite simple. We used some welding and a little bit more. This space has worked really well. This is being celebrated. This is the carnival festivity, and joining the people into the design process made the space to be more collaborative. There was a problem with dump and waste, and this has disappeared. And here we had Patricia celebrating the carnival in Pinto Salinas, and they created a cake with the shape of this common space. And later on, we have these youngsters having being trained, and with the rests of the work site, they created through the same triangle system this basketball site for them to play. Then another similar project is Urban Spa in Chihuahua, which is in the north of Mexico. In the border with the US, there is a great problem with violence, which is now reducing, but this made people not to get out on the streets, and the usage of common spaces or public spaces is not very high because of the fear of people. We work with the university in Chihuahua. We started with a collaborative process in Parque Ureta, in Ureta Park, which was quite neglected. We started to see what people really wanted and what they thought about this particular space, what we could do with it. We also had only 1 month, and with an almost zero budget. Everything was through donations, and people wanted to use again a fountain that had not been used for 7 years. We used a different prototype, several proposals, talking to users, talking to the people in the community, and we reached a common proposal to create the fountain into an urban spa. We all worked together. Students worked as well, and it was very interesting that people from the neighborhood also started to volunteer and to work in a voluntary way with 70 people, which we didn't even have enough tools for all of them to work. And we finally built this urban spa, which was a kind of public swimming pool without any rules. You could go without any swimming costume. You would just arrive, and we managed the city council to repair the fountain. And so the city council helped us a lot in the project. And what is more important is that this part was a temporary experience. It was done through palets and some shadows. And the most important thing here is that when it was taken away, people were really angry, and people were arguing and are trying to work again through neighbors associations, and they are reporting the city council. They want their urban spa again. They want it back, and they don't want to have the city council doing everything, but they want to define by themselves how it is going to be, and they will contribute to their creation. I will now show you a short video about it. It is important to see social relevance and how this all channels social transformation. And in this case, it is coming back into the streets and using again common public spaces, which is very difficult if it's not done in the community. The next group of projects have more to do with the domestic field. They are called Home a Home, and they all have to do with this diagram, which shows the evolution of the price of incomes. We have red line price of houses, and then blue line is incomes. So it is 2.5 more and nine times higher. Our houses are 3 or 4 times more expensive, or 3 or 4 times smaller if we link this to the real estate bubble, etc. in Spain. One of the main problems that we worked in Home a Home is that all youngsters or young people between 25 and 30 people were already independent and had to come back to their parents' house. This is the case of one of the students. She had studied fashion design, she lost her job, and she had to come back to the room where she had not been since she was 18. So she can see Hello Kitty and all her teddy bears, and above all, her parents. They are your roommates. In Home a Home, the target was to help in the temporary transformation of this room, because you are now 26 and you left the room when you were 18. All the cases are self-financed. So we worked with the Institute Do It Yourself and with several universities, and this is the case of Edurne. And we have a series of students and participants, among which we were there, and we started to think how we could change her room. She had a problem of space, a functional problem, because she couldn't sew anymore. And then you are psychologically quite depressed because you don't have your job anymore. So you need to use your room as a platform to be independent again. The important thing is that Edurne started a transformation process together with different experiences that we all did together, and the design was a totally open process where many people were thinking about this launching space, which was her room. We created this piece of furniture because she wanted to sew again, and she wanted to do it again. It was very functional, and she could sew up standing or sitting. This is her room, and then we wanted to leave more space in the room so she could have time and place for sewing up. And she started to create a new collection. We may not say that her life has changed, but she has now a new role, and this project had a target of social transformation. Then we have Pequeñas Casas project. This is done by carpenters, and they create mobile solutions for very small spaces, because we normally live in very small houses, which are more expensive, and we truly have a space problem. We have a real estate park which is quite poor, and it responds to social problem, which is a Catholic couple having a child. So we start to have new children, children live in their houses. So we normally have small houses, and we try to generate designs and co-designs with these kind of users who are demanding new ways of life and new lifestyles, so that their houses adapt to their lifestyle and not the other way around. They want to be able to transform their environment. We have 3 prototypes that are already finished. We are now creating 3 new more. And there is no profile of user, because in general, almost all of us have space problems and adaptability problems in our houses. She is Yolanda. She went to her grandma's house, and she wanted to make it her studio and her house. These are Enrique and Maria Jose. They are Mexican and Spanish. And they wanted to have a second house in Asturias, in the north of Spain, where they wanted to spend some time and how to make a very small flat be a place where grandsons can come and can sleep there, so and it can adapt to their different needs. This is Estela and her family. And part of her family, she is Colombian, and Michael, his husband, is English. And they receive thousands of visits, their mothers-in-law, friends, etc. And they wanted to have a guest room without losing space in their living room and be able to use it differently depending on the circumstances. And I will finish now with some videos so you can see how this all works. The manufacturing is not open. We wish we could do open manufacturing and so that previous experiences would be used in the future. This is one of our challenges, but the design process is truly open, and this is managed with the users because it is very customized.
Un vídeo donde estaban mostrando. La primera vez que te lo dije me dijiste que estabas loca. Sí. Que cómo íbamos a tener una cosa tan que se movía por todas partes. Además tienes que acostumbrarte a que, sí, pero eso está muy bien, o sea, puedes aprovechar todo. A uno todo se puede cerrar y se convierte en espacios cerrados. Si estamos nosotros dos solos, toda la casa se vuelve un espacio.
Darle a un pulsador como ese es suficiente. Y bueno, pues de ahí surge de pronto todo lo que nosotros queríamos. Tener un espacio que fuese funcional, porque recibimos viene la visita y tienen su habitación. No duermen, tenemos un comedor, y tenemos un espacio para que los niños jueguen y nuestro salón.
Well, this is it. Thank you. You can see here Pequeñas Grandes Casas. This is our project, and Pac-Man, which is our company. Thank you. Thank you, Carmelo. Now, David, the floor is yours. You can have your presentation now. My name is David. And my studio is totally different to the previous one. I'm a founder of a free software platform. And I'm part of the open software movement at world level, how any physical element moves. I work as a professor at the Malmo University. And I will briefly talk about our vision of open manufacturing. So to provide you some context, I started in 2003 to design electronic devices to work with my students, circuits with my students. I wanted to help them to create interactive designs because in the future they will be designing everything in the future. They will work with digital technology, and it is very different to people used to working with wood, plastic, etc. So I realized we had this specific need. We did it in hand, with our hands, and it took around 12 hours. It was handmade. So we tried to simplify the whole process, and the circuit was easier to build until we reached to have this design, which is totally machined, and millions of units have been sold. How many? I don't know, because one of the keys is that this is totally open without any brand, so any company, public entity, or individual can copy it and sell it and get profit from it. What did people do with this? Well, these are some instances. Maybe you cannot see it properly, but we used a car, which is a Chevrolet Captiva, and this is driven only with music. Everything is done with digital elements. The controls are made with wood, and the car is driverless. Is a driverless car. Not only circuits are important in this project. Apart from the circuits, we have a software to program the circuits because they cannot be programmed alone, and we have a system, an open and free to use system to study how to work with digital electronics. Our vision was to help people learn about electronics, and we needed low-cost tools, software tools to program them that would be totally open, and then contents that would be also open. You have of course the choice to buy it from another person. As part of the open manufacturing movement, we have participated in the discussion of open licenses. For those of you who are not familiar with it, these are called the Open Software Hardware Association, the OSHWA, and this association established the basis of free software. I will explain some principles which are very similar to free software principles. These helped all different actors to understand how important it was to have a license for physical objects, not only electronics, but if you have a chair or a design of a car. And Fern, which is something we all pay in some way, we paid for the first license for free software or open software. I will answer some of the questions that I received per email. And one of them is, what is it? What is it? What is open manufacturing? For me, open manufacturing is creating physical objects and offering the rest of the society all designs, not only of a physical object, but the whole, all the things that you will need to implement it. I may use a certain type of wood, so we can replicate it. I will give you some examples. I am designer, or one of the designers of these circuits, which has sold millions of it. There are clones of it all around the world. Many companies use it as a basis and give jobs to millions, to thousands of people. I don't do that every day. I sometimes do different projects. I worked with children in Esteparapa in a neighborhood in Mexico, and I created electronic circuits with them. I explained them and taught them how to use them, how to make them, and I asked them, what do you want to do now? And they said robots. So I started to see where could I find components to create robots in Mexico. And as I created a free software, I included some wheels and the system. So with a minimum cost and a very short investment of only 1 month, we could create an open system so they could learn about robotics. And then this is one example of the results of the projects. I like to have this example because it is a breakthrough. This is a Eddie, which is a marijuana smoker egg. Then we have a research blog in Melbourne University, and the design was there. These guys continued creating these once a year, and then suddenly one student told me, I would like to create a robot, to manufacture a robot. And I said, look, I have this in my collection. This board that I had already done from a previous design, I gave it to this person. Then I also have another free product, which is a robot to learn about technology for kids. Here we have a physical interface. We have a smiling robot called Kubato, a physical interface board. This is made with 3 parts: the robot, the programming. So you start using the pieces. Each of them will reproduce a movement depending on the piece. This was done through an evolution of a prior design that I already had. The fact that it is open helps us to rethink about designs and being reused every time. And this is something you can buy at this guy's company, and it gives us nothing apart from publicity. How is it affected by emergent tech? How is open manufacturing affected? This is a very interesting case of Bitcraze. Bitcraze is a very small company. This is a 4-people company, which is now in a hub or an incubator in Sweden. This company creates the lightest nanocopter in the world, which is they manufacture in China. They are only 4 people. They have created the design, and they collaborate with a C studio, and this is a studio who manufactures designs, and they offered a discount if it was open design, so they could use it for further customers. So they manufacture this nanocopter for them, and this is an emerging technology. There is a lot of competition, but there was no company creating one weighing less than 100 grams. But thanks to this manufacturing in Shenzhen, we started to see new companies manufacturing nanocopters, which are obviously copying their design. But then this person had the idea of, instead of competing with the persons or with the people copying him, they tried to collaborate with them. They created compatible parts in these nanocopters, and then other things that you may use for toys. They are not reprogrammable, but a big part or a big part of their architecture are very similar, and they could save a lot in their manufacturing and lower the cost of the final product. So the fact that you have open manufacturing enables you to reduce cost thanks to the collaboration you have in your environment. Another question we received is, how is the creative process affected? Here I would like to introduce the piano, the cat piano. This is an example with Arduino, and it sounds perfectly as a cat piano.
It's not bad. There's hundreds of projects like these, and that's what we do, is we try people to make a connection between music and technology. We do some projects with different schools around the world, and we can see all kids that with no limits, their imaginations, but if it has something to do with music, it tends to be more popular. We have seen all these huge piano, like the one of the French musician Jean-Michel Jarre. This is a system that we're trying to do it in Navas, for example. In Catalonia, there is a couple of teachers, and what they do is they teach students music lessons and small instruments inside of milk boxes, and they make all these instruments, and they teach music to all these students with very modern instruments. They don't use the classical flute, for example. They use all these new and improved instruments. You can see, as you can see in the video. We could continue with them for a long time, but I don't really have too much time, so I'll try to focus my presentation. Another question that I need to answer is about the collaborative economic models. I've given a few examples because all these ecosystems are very interlinked. When you manufacture something and people can use it and they can create a business model, you can help the people do that. One of the business models is the 3D printing. Most of the 3D printing, the printers actually work with an Arduino board inside. This is one example in Sweden as well. We started this design based on the design of a Spanish inventor, a Spanish guy. So there is a whole environment of companies working on basically technology based on Arduino technology. People copy their Arduino boards, and what they do is, because these boards are free and open, it's given them added value for people to wanted to use them. Another curiosity is something that we did with a Spanish company Telefónica. In this case, we started a communication board to be able to connect to the GRSM network, which is the cheapest one. You can actually build a circuit with a radio, GSM radio, and you can actually send it to any country that uses this network and start to communicate. This is very cheap actually to use. The problem was how to get a card for this international roaming. So what we did is we started a cooperation with Telefónica, the company. We would give them the community of users, and in exchange they would be able to give us a card, so we could actually use this international data card to be able to use it for free. So this idea of open manufacturing opens new synergies, because you might be able to manufacture a circuit, and then you need other actors in order to implement new projects. This is another video where I explain how this system works. I'm trying to make a phone call to my mobile phone from this, and I made a mistake. Actually, I introduced my real phone number, and I received all these messages from people actually telling me, is this actually your phone number? Right. To conclude, I'll give you a final example. And we talk about opening sources, designs, hardware, software. This has to do with the old cooperation with some of my old students. Have a company called Talk. They do design for mobile phones. One of their big clients is Samsung. They started this software that controls interactions between tablets, telephones, and PCs. What they did is to map this interaction from a mobile phone to a robot that we created for education. It took them only a couple of hours. It was very easy for them to be able to patch all this communication through the different devices. This is Michael controlling my robot, actually. One of the big added values is that so we keep working with all these technologies, so the time to develop new things is reduced because we're working constantly with them, and that's it. Thank you very much.
And now, Peter, please.
Thank you so much. Thank you very much for having me. And please excuse me, I don't speak any Spanish, so you're going to have to do with my slightly Scottish-enhanced English accent, because I used to live in Scotland for 4 years. I'm now in the Netherlands for the last 10 years, and almost all this time I've been looking more as a researcher, but also as a kind of activist into this arena of open manufacturing. I'm currently working as a research professor, and my topic is actually the revolution in manufacturing. And this is at Rotterdam University of Applied Sciences in the Netherlands. And I'm looking at the impact of those technologies and practices that we've just seen in examples the impact of readily available direct digital manufacturing technologies. You know, when you're academic, you have to make complicated words to make simple things lifted to an academic level, isn't it? And the design and manufacturing practice of fabbers and makers, exactly that stuff that we just saw, those robots and those kind of things, and how that impacts on what we know in industry from the past 100, 200 years, and what we see emerging in terms of new businesses. And we've just seen a couple of examples of these businesses. On top of that, but I'm not going into that today, I'm looking into educational principles, and again, we have a lot of common ground there that we could explore. And I'm also looking into how cities develop and how urbanism develops in the face of these developments. And eventually, I'm interested in finding out how the relationships between people and tools and people and capital and people and authorities need to change in face of these developments. Over the past, say, 3 to 5 years, I was sort of collecting all sorts of examples and evidence, and I would argue that what I call making, this idea of open manufacturing, direct digital fabrication, fab labs, makerspaces, etc. This started some 15 years ago, which is actually 5 years before the term making was invented. That's the second bullet point there, and this was sort of the fab lab that was set up at the Center for Bits and Atoms at MIT in Boston in the United States. The maker movement probably started with the RepRap that became available, this open source 3D printer that is sort of the basis of those hundreds of desktop 3D printers that are available on the market right now. Maker Fairs, Maker Magazine started in 2005, 2006, and the Fab Lab network, that's an interesting story, was initially designed as a number of outreach labs that sort of would connect MIT researchers to some developing countries and, you know, doing some greater good while developing the big thoughts. And this totally spiraled out of control. The initial idea was to have something like a handful, say 5 or so fab labs. And we're looking at something between 500 or 600 fab labs right now, 15 years after the idea. Important thing, don't forget there was a world before 2001, and there was a world before the internet, and there was a world before Google, and in that world, people were also making stuff. But the important shift, really, that happened in the very beginning of the 2000s, the noughties, as they're called in English, is that making started to use digital fabrication, digital manufacturing technology at a desktop level. And I think that's the big difference of the big promise of what Fab Lab is and what we're seeing with 3D printing on desktops compared to the larger makerspaces, the Fab Labs that use robots, the tech shops of this world. If I dig deeper into making and look at the practices that emerge, there just was published a report last week by the Royal Society of Architects in the UK, and they have a slightly differing notion on those findings, but essentially confirm there's one strand which is sort of really the hedonistic pastime thing, white middle-aged men instead of riding horses or using sailboats, going to makerspaces and play around with robots and 3D printers and stuff. There's another important strand which really links to a lot of work that we have seen today, is that making is really an innovation in technology education, what's called STEM education, science, technology, engineering, maths, something that people believe is very important, that we all learn about technology or learn about engineering. Again, we could have a lot of discussion on that, if that's really useful, if that makes a lot of sense. If everybody needs to learn to program, if everybody would need to actually 3D print stuff, I think the important bit there is that people learn again that technology is man-made and not God-given, and that if technology does something in a particular way, that somebody sat there at a desk and designed it to work like that. but we could have designed it completely the other way around. That's the important thing about technology education. Then there is this romantic notion of the reconciliation of liberal arts and science and engineering, that those two fields that sort of were taken apart in the Enlightenment, sort of here is the liberal arts, the artists that are doing fancy stuff, and here is serious engineering where you really have to work. This comes together again. I think this is a bit naive, and probably getting back to that on one of my last slides. And the last point I really see, there is a potential revolution in manufacturing. And again, we've seen a number of examples where people really are doing that. They're reverting back to small size manufacturing, to network manufacturing, to distributed manufacturing, and to structures that are not hierarchically controlled, but are essentially based on a network and based on collaboration. This revolution results in new industries, and the Arduino Genuino example is one of those boutique manufacturing industries that is able to use their clients not just as the consumers that buy the stuff, but clients that become ambassadors for the products, become even product developers. We see a lot of that happening in the field of 3D printers. Clients that become usability experts, become marketeers, even business developers. You know, the guys that copy a board and resell it in a different configuration, for instance. Those boutique manufacturing businesses often start to look into paths of reusing, repurposing, recycling products. They're built on stories that connect business and products and clients. And from a sort of economic perspective, it's really interesting to see that these small companies, they're prototyping the products that they're developing, but they're also prototyping the business models they're using, which is actually quite a novelty, and a lot of research has gone into studying business models the past 20 or so years, and we really see that prototyping a business model is a new approach to developing a business, which is part of that revolution. But then, of course, we've got the incumbents, the existing industry, and they also see, hey, there's something going on. What's happening there? Can we sort of integrate that into our corporate systems, traditional industrial systems? And often that's then labeled as a way of innovation. Some companies build their own internal innovation garages, internal fab labs, internal maker spaces, proto spaces, whatever they name it. And others practice what's called open innovation, which essentially is not the open manufacturing we're talking about. But open innovation, when you hear a businessman talking about open innovation, he usually thinks there's a lot of intelligence out there. How beautiful would it be if everybody out there would give their ideas to me so I can make money? That's essentially open innovation, large-scale operations to harvest ideas and innovation publicly for cheap or for nothing. So this is not exactly what we understand with open manufacturing, where the relationship between manufacturer and the client is really balanced. I had to add that slide about open manufacturing and thinking, what really does it mean? Because you know, we've had the term open manufacturing, we have had the term of open source hardware, we have had the term of open design. So this open manufacturing comes in. What does the open mean, and what does manufacturing mean? I think that manufacturing, I sort of compare that to making, where I say manufacturing is really is beyond that practice of making, which is producing for a market of one. I'm doing my own things for myself because I can, or technology as a personal expression. Manufacturing really means adding economic, ecologic, and social value by producing artifacts. Of course, that's at the core of manufacturing. And then, you know, with the open, there is a danger of that open washing. We've heard about wiki washing, greenwashing, etc. So the open washing of anything. I've alluded to that when I discussed open innovation briefly. So what really has been closed about manufacturing. Well, you know that saying that freedom of the press belongs to the one who owns one. So the freedom of manufacturing belongs to the one who has a manufacturing plant. And actually open manufacturing is this trend to open up manufacturing plants to other people than the plant owners. Now, to conclude, because I'm supposed to be within 10 minutes, when I look at the current developments where we stay now, there are a few points that I think are sort of, which I would label as failures. Of course, one thing is, and we always get that in tech, that tech is male-dominated. And open manufacturing, open design, open source hardware is primarily male-dominated. There are a few say female projects or a few women actually working in open source hardware. So there is light at the end of the tunnel. Second point, a lot of the projects are really kind of nice to have and not need to have. They're idiosyncratic projects, you know, people just pursuing their own personal private vision. Open manufacturing is often a privilege of the rich and well-educated. Now, we've seen your examples, your projects in Mexico. I think that's going the right direction. Of course, then we could think about, isn't that a new way of colonializing Mexico again through white guys coming in and bringing them technology, which is a very interesting discussion, which we need to have. A lot of open manufacturing is sort of corporate-friendly, has this neoliberal touch that, yes, innovation is important, and we want to be entrepreneurs, and we want to grow up, and there is a lot of open hardware projects that are trying to get somehow into venture capital and get rich quick. There is this idea of objectivism and technocracy, that technology is neutral, which I think is not. So there are a number of challenges we need to address, I think, in the coming years on if we develop open manufacturing. We need to become socially relevant, and I'm happy that we have seen socially relevant projects today. We need to look into sustainability, into ways to create circular products. Eschew stardom, which is kind of difficult because I'm standing here as well as kind of this academic starlet that is trying to convince you of his intellect. We need to really become inclusive across gender, across society, across class, across the north-south divide, and so on. We need to look into the ethics of technology, be critical towards economic power, political power, try to be non-elitist, and really see that development as a socio-technical, socio-economic development. That's it from me.
Muchas gracias, Peter.
Extremely interesting, the last point of Peter. I think we ran out of time. This is 5 past. It's just more than... We only have a few minutes, so we give you the floor so you can actually ask any questions for Peter, David, or Carmelo before we finish. I can't really see you because of the lights. If it's any questions? Apparently, this is have you had an easy access to financing in open manufacturing? Well, we do zero financing ourselves, so it's not even easy. Well, Arduino started 10 years ago. It's the first project of hardware, open hardware with certain success. When we asked an investor asking for money, they would say you don't have any patents to protect yourself, so they would kick us basically. what we've done is we've changed the perception of the value of culture, not just ourselves, but everybody that is working in this area. And when you go now asking for money and telling them this is a free and open project, they will look at you with different eyes. They will ask you what is the real value, the social value of your project, and they can actually see that they can take part in a different way. We started actually funding it ourselves. Now it's easier. I think it's even a bubble. If we include stuff that Peter has said, we could actually say, oh, we've just invented this bubble. It's okay, here's $2 million. I think it's even too easy today to get financing. Well, I believe that, okay, this is my vision in architecture. It's not a question of products, but opening decision-making processes. In certain ways, it's similar to your product industry. The projects that we have actually carried out don't usually have funding. You can see that they are they're a bit crazy, and that's something that we actually share with you. And we work with different agencies, universities, and with very low budgets, to be honest. Let's see, is there any other question? Just a final question before we conclude. For those who those people that haven't gone to open manufacturing, who don't know anything about it, what can you tell them to lose all this fear, as you have actually mentioned, that sometimes manufacturing is in the hands of a minority. But we would like to know what's your idea about how can we break some barriers because of a lack of knowledge. Peter, for example, what could you tell to new people in this?
Right. Thank you for the translation. Brilliant translation. No, certainly one way to get into that field of open manufacturing is to see if there is nearby a makerspace, a fab lab, a tech shop, a hackerspace, where people really are experimenting on a sort of entry level with this kind of technology. And you know, I've talked about the Fab Lab network, which is about 600 Fab Labs globally, and about half of it are in Europe. So certainly in many major cities, there are those Fab Labs available, which usually have some kind of low entry barrier access. Some operate even on a partly free access level. There are many schools that are looking into integrating these kind of technologies and ideas into their curriculum. So there's a lot of opportunities out there.
David, right. Okay. I agree with Peter, with many of the things he said when he wrote this list of the challenges that are ahead. And I think everybody has the choice is open to everybody, but the access is not ready for everyone. There's a lot of things going on. For example, in the Arduino forum, we have this standard forum, but most of the discussion forums are dominated by males, and there is a dynamic established by males, and this is very hard to change. So from the moment that you have this situation, this is not inclusive. It has to do with the way the information is shared, is uploaded, the comments, etc. So the limitations that we have in terms of research is that we still haven't devised all this or understood these inclusive tools. And this is one of the keys, in my opinion, to go forward. how to share this information to anyone. Carmelo? Well, I've actually have a question for them. Historically, the transmission of knowledge has always been within the family, top down, from parents to children, from the eldest to the youngest. And the digital culture is changing this paradigm. The youngest is actually the one that knows the most, and he has to start learning, teaching his parents or his grandparents. I think this is a radical change in terms of paradigm, in the way that we have been functioning in humanity. What do you think about that? How do you think in the culture, in the digital culture, this is being faced and dealt with? Well, while Peter listens to the interpreting, I'll ask the question. I personally do not believe on a top-down model of information transmission. I believe that we are in front of a huge possibility in history of being responsible of communication, of Arduino. I've been learning and studying all the United Nations, UNESCO documents. And one of the big problems that I have actually found is that French is actually growing in communication, and we will not have enough teachers, language teachers. And the only way to solve this problem is through digital education, distribution of this education. We have to abandon this model of one teacher for 30 students. This model doesn't work anymore. So I think we should actually change radically our paradigm in education, how to educate people, because things are happening now, and if we want the knowledge to work, we have to accept that the educational models, one-to-one, my father teaches me and I teach someone else, might not work, actually will not work, because we might be in the future in a different situation. But right now, there's a huge gap between those who know and those who don't. So we need to find a way of disseminating this information which is different to the one we have right now.
Peter?
Yeah, I totally agree with that argument. And you know, on top of that, I think we're faced with a situation where a lot of information actually is available through various networks, and that's one thing. So it's not that situation we used to have like 20, 30 years ago, when the knowledge was with the teacher and you had to go through the teacher and through the libraries to acquire the knowledge. That's one development, and that requires that we learn to navigate that information. That's a very, very crucial skill. And of course, as academics, we have learned to navigate information, but that becomes really something that everybody needs to be able to navigate that abundance of information. So that's one thing. And the other thing is that certainly currently we're in this shift where a lot of technological changes that we have seen coming along suddenly start to have a real impact on society, which requires a lot of people to retrain, to learn new stuff, to sort of go back to school. And we know that students that we teach now or that study now with us, that they will have to keep learning for their whole professional life. So one important skill that people really need to acquire is to be learning all the time while navigating that sea of information. And that's the fundamental change in education we're talking about, I believe.
Okay, now we will conclude. So thank you very much, Peter, David, and Carmelo, and thank you all for being here today. Thank